Learning plan number 6 here. This is dimensioning, and as you can see, we're kind of at the tail end of our course. We just have dimensioning and then engineering drawings to work on before we're going to be moving into our next class, which is working drawings. So today we're going to get started on this. Now, this particular chapter, chapter 7, is divided nicely into 2 sections. So the first lecture that we're going to do here is going to be a review of the dimensioning and really looking at rules and how to do things. It's that kind of necessary thing, and it's actually probably one of the most important things that you need to do in a drawing. Creating models is great, good geometry, fantastic, wonderful, but remember, these parts need to be made, and they need to work and probably in some cases made together and function. And you as the designer are the person that sets that up. So we're going to be reviewing some of these standards, the rules that we've learned along the way, and kind of refreshing ourselves before we start officially making engineering drawings using Creo. The second part of this chapter then is making actual drawing borders so that we can use those for our parts going forward. So it's kind of broken up into 2 separate sections. So we're going to start with the dimensioning rules and looking at what we have in the book here for that. And then the next time we meet, we're going to be doing the format sheets, templates, and drawing borders. Okay. So let's kind of get into that. What I'm going to do is I'm going to go underneath my camera, and we're gonna go directly from our chapter. They do a nice job. They have some nice examples here. So rather than, I didn't do a PowerPoint because I just find sometimes it gets distracting going back and forth between the illustrations and such. So we're just gonna kind of work through page by page here, point out some things, and then get familiar with the rules. The purpose of this is not to make you memorize these items, but to just kind of bring back into the front of our minds. It's been a while since we've officially dimensioned, and then also get some ideas and good illustrations here from the book. So chapter 7 starts on page 197, and I'm going to kind of turn the page here, and again, we're going to be looking specifically at some areas. I have some things highlighted to remind me to mention some things, but we're going to be focusing on the illustrations that we have here. So first of all, it talks about in the beginning here how important it is as the designer to really understand the good dimensioning techniques, and then most importantly, what the rules say in terms of the ASME standard. And so that's what we always work from here in mechanical design. Now, as you work for companies, when you're out in the work world and in industry, companies might have their own specific ways of doing things, and that's okay. And a lot of times that's to standardize, based on, how they do things. For instance, when I worked out in industry, after I graduated here from LTC, I was working at a company called Hyson, and we made high-speed packaging equipment, and the company had been around for quite some time. And they had certain places that we would put, like, the material size. It was right above the title block, or where we would put our notes, or how we would dimension certain things. And we actually had a department of, I think it was 3 people, now that I'm remembering, that would actually check drawings before they would be released for production. Okay. Now that was typical of the time. And since then, companies have eliminated things like drawing checkers specifically because they feel like, okay, you should be able to check your own drawing. So it's really on now the designer themselves to be sure that their drawings are, number 1, to the ANSI standard, number 2, following the standards that a company may have specifically. And number 3, the parts can be readable by somebody who's making it. And that's really probably the most important part. Well, I should say, and 4, that it functions, okay? But if our drawing is out there and we can make the most beautiful drawing and it looks great, but if it can't be made, it's worth nothing, okay? So your job, you have to think of a lot of different things as you are creating your designs. You have to think about, the dimensioning standard. You have to think about your manufacturing process. You have to think about the cost. You have to think about the function. You have to think about the customer. You have to think about the person who's going to be making it and what they're going to be looking for. So, so it's a big responsibility. So through our program, we get a lot of practice. So here's just another opportunity to like kind of take it in again. When many of you have taken SolidWorks and kind of, that's where SolidWorks and AutoCAD, we've been like kind of got in there in Dimension. Here's a third look at it. Okay, so so you're probably going to pick up another thing here. Usually, when you see it the first time, you get a chunk of the information. You see it the second time and you practice, you pick up a little bit more. Here's another opportunity to pick up a little bit more. Okay, so but this is also here for your reference. And I'm going to point out some things that I did find as I was going through that actually aren't to the standard. So so we'll talk about some of these things. So down here in the lower left-hand corner, they're just kind of talking about, you know, good placement of dimensions and spacing. So when we're looking at a drawing, for instance, you'll notice that we want to make sure of a couple different things. We want to make sure that things aren't crossing, that they're not on the part itself. We're pulling dimensions off of the part. Should all sound pretty familiar. That we have our gaps between the actual feature and where the dimension starts, because if we don't have those gaps, then it starts to look like a continuous line, and we don't want to create confusion. So as I look at this, this is really, I mean, for the most part, really good practice of what they're doing. We also want to dimension, you know, in views where we see parts as their true size. For instance, when we see a hole, we want to dimension it its size. We're in that view where we see it as a circle. Additionally, where we see it as a circle, we want to put its location. Okay, so you can kind of see everything about these circles or these circular features. Location and size are all in the same view, and that's a good practice. You don't want people looking around, you know, on the drawing to try to find this information. It kind of takes time to do that, and time is money. So, and it also can create potentially confusion or somebody not finding it. So try to cluster, if you would, size and location dimensions all in the same view, okay? Additionally, you'll notice that they're using some standard symbols here. So over on the left-hand side, we've got these counterbore holes. So you can see the diameter symbols. We want to use those. In previous standards, we used to, instead of the diameter symbol, we would use DIA for diameter. And so you'll see that on older prints, and sometimes it crosses over with designers who that's what they've gotten used to doing. But the current standard has symbols, and it's that circle with the slash through it. We want to use that ahead of the dimension to identify a diameter. Additionally, here we have a note with a depth, and that's going to be the depth of what here is the counterbore. So you want to use the depth symbol, not write out depth or DP after, okay? Again, you'll see that on older prints. As you create new part numbers, maybe even from older prints that were created in CAD, you'll see those types of notes. And what you want to do then is you want to convert them over to the current standard. So because, you know, we want to kind of bring things up and be able to have things recognizable. Additionally, when we have features that are in more than one place, especially when they're obvious, like over here, you can see the height of this cutout here is a 1/2 inch. Well, that's for both of them. Why dimension both of them if we can do it over here? So adding the 2x in front of that is completely good and legal. There is probably one criticism that I have on this particular drawing. And one of the rules, and this is in the ANSI standard, is that every dimension needs 2 arrowheads, okay? And sometimes people do this because they think it looks nice and they're saving space, but actually it's not to the standard. And you'll notice here when we look at these 3 dimensions all in line with one another, do you see how they don't have 2 arrowheads for the 0.44 on the left or the 0.44 reference on the right? Now, adding reference on the right is totally fine, okay, but we should scooch these up or down so that they both have their own 2 arrowheads for that dimension. So I know this saves space and it's readable, but it's not to the standard. Okay, so that would be the one criticism that I kind of have on what's going on here. Additionally, we try to put our dimensions between the views for features. So this looks really good. Overalls a lot of times are on the outside, but sometimes there's just not enough room. And so pulling dimensions away that are, like the 0.412, that's perfectly fine, perfectly fine. All right, so and then you want to just step back and just make sure that it's all readable. And again, making sure that as we're dimensioning features, that we kind of give all their information, both size and location, in that same view or in the same vicinity. Okay, any questions here? Okay, all right, so just kind of remembering that stuff. Let's see here. They talk up on top here about spacing away from the part. So in Creo, or in this particular book, they're identifying that the dimensions shouldn't start any closer than about a ½ inch away from the part. I'm not going to say that that's a hard and fast rule. I think it's a nice general guideline because I think it looks good. It kind of separates then the dimensions from the part itself. But if you're a little closer because you're trying to save space or get something on, I think that's fine. As long as you're not like right up against it. You know what I mean? So again, some of these things are guidelines, are good to keep in mind, are good to try or maybe space out to start out with. But hard and fast rules, not necessarily. We're going to find when we set up our dimensioning on our, we're going to call them format sheets, we're actually going to specify these two, but you can always change it and adjust on the fly in the actual drawing. It'll be like when Creo creates the drawing and puts the dimensions on automatically, they'll use these guidelines, but then you can always move things around. Okay, just like we had in previous other softwares. So spacing there again, guideline, not necessarily. It's not a standard to the ANSI standard. Just trying to look here. You know, things to keep in mind too. We don't want to be crossing dimension and extension lines over dimensions. So it's good practice to put shorter dimensions closer to the part than the longer dimensions. Because if we would have the 2.782 up here, we then would have this dimension line or this extension line crossing the dimension, and we don't want that. So always making sure that you have your shorter dimensions closer to the part, your longer dimensions further away to avoid that from happening. Never dimension to a hidden feature, and that includes center lines of a hidden feature. Okay, so we'll probably see some examples coming along here. So you'll notice here that in this case we have the diameter of 1/4 inch through for the hole and the counterbore where we see it as object lines. If we kind of look down here, you're going to see there's a counterbore here, not necessarily the same one that's there, but we would not dimension a counterbore in a view where we see it as a hidden line. You can't point to that and say, oh, that's what I'm dimensioning. No. Okay. So make sure. Now, when we do our dimensioning and our detailed drawings for Creo and other parametric software, it will kind of give its best guess at where things should go. And it'll use some guidelines, and in some cases, it'll be fine, okay? But in other cases, we are still the human that makes the decisions about where these dimensions need and have to go. And we're also going to be adding any tolerancing that's appropriate. So we can't just say, oh, when it's done, all right? You still are going to be putting eyes on this. So if Creo dimensions to, someplace it's not supposed to, again, remember it's a machine. You are the human. You still are responsible for putting dimensions where they need to go or changing their orientation and such. Down here, it's talking about leader lines. Leader lines, when we put them in place and they are for a circular feature, they need to not go to the center line, but if I were to extend this leader line, it would extend through the center of the feature, okay? Creo will put that automatically on there, and if you move this note around, it'll actually maintain that, okay? So, but if you add a separate reference, you need to still, abide by that, okay? Additionally, your leaders need to be at an angle. They can't be horizontal or vertical. Cannot be perfectly horizontal or vertical. And the best positions are, I don't know if the standard says this, but I've seen this in a couple places, 30 to 60 degrees. They're using 20 to 70, kind of giving you an extra 10 degrees, and that's fine in both directions, but not vertical, not horizontal. Okay, not vertical, not horizontal, and not real flat. Anything that's real flat looks funny. Okay, so make sure that that's the case. Additionally, we need to have this landing. We cannot start a note right at the end of that extension line or that leader line. You have to have the landing and then start the note, okay? All right, so those are just kind of some things. What I also like to tell students as well is if you go back to this chapter and you see something dimensioned, then you know that that's the way. Then you want to try to duplicate that. Don't come up with something, you know, on your own, if you would. Another reference, many of you have had GD&T with me. You have that little blue book, okay? When we add GD&T to some of these drawings, we need to make sure that we're going back to a reference that we know is to the standard. And if we see it in there, then we know that that's a valid way of showing it. You cannot make up your own way. There's a standard established for the reason of people not going off in different directions, okay? Because potentially your drawings are going to be not created, or the parts are not going to be created in the same building that you're in or by people that you can go out and talk to. It might be in a completely different facility. It might be in a completely different country. And the standards are there so that everybody is speaking the same graphical language. Okay? All right, so any questions on this page so far? All right, should again all be review. The next subject here talks about fractional and decimal dimensions. Now, previous to CAD, fractional dimensions were very common. So especially in the English system, we deal with, and we still talk in terms of 1/8, quarter, 64th of an inch and such. And there's really one area that we see it most often, and that's when we call out standard sizes of fasteners, like a 1/4 20 UNC socket head cap screw, okay? A lot of times we're gonna see that note as 1/4. But the new acceptable way to identify all fractional dimensions, even on their even fraction, is to do their decimal equivalent, okay? And then that decimal equivalent is gonna have decimal places that are then gonna correspond to our title block, where we will then have our standard title block tolerances. So we do not put any decimal dimensions on new prints anymore. If you get an old print that even in CAD has some fractional dimensions on them, the title block should give you what that title block tolerance is. So many times a title block tolerance will be something like for fractional dimensions plus or minus a 64th of an inch, okay? That has to be in the title block. New title blocks don't have the fractional equivalent anymore, you'll notice. Okay, so we don't put fractional dimensions on new ones, and if we're creating new part numbers or redrawing old parts, we bring them up to the standard, and you would then convert those over to the appropriate number of decimal places that is in accordance with the tolerance that you're trying to hold. Okay, so again, you're going to maybe see them. Probably the most common place where it's still okay is when we have fastener callouts that are to a fractional denomination, but we do not put any fractional values on a drawing. Okay, so what they did over here, this is just a chart going from fractional 2-place, 3-place, and 4-place. All right, we can do a simple, calculator, figuring out on a calculator, dividing the top by the bottom, and then we can do our own too. So you don't necessarily need a chart here. But then the decimal place is going to be either defaulting to the title block for its tolerance, or you're going to be specifying an actual tolerance in back of that particular dimension. Okay, so it has these here as well. Standard sizes that are preferred. So for instance, in the English system, we like to be on the 64th, 32nd, of an inch. All right, those are our natural standard sizes. Try to do that because not only just for knowing that it's, for instance, a 1/4 of an inch, but especially when we're creating internal features like holes or slots. Those tools are made to the standard sizes, which are the fractional equivalents. So, for instance, if we have a 1/4 inch hole, we want to call it out to 0.25, not 0.2513, whatever. Okay, you want to call it out the nominal size and then apply any tolerance that would be appropriate. Okay. Additionally, and this is something that I'm not sure why I got into this book, but and this is one of the things that I'm like, no, this isn't quite right. But when we call out, and it has this note right here, preferred standard sizes, even though we know there is a 1/4 inch drill, we never put drill in back of the size of a hole. We don't say that because it really denotes then a manufacturing process and a tool that you have to pull to make it. We are not in the business of deciding how that specific feature is going to be made. If they can make it in a different way using a different tool, we're giving them the freedom to do that in manufacturing. Okay, that's their decision to make. We want to leave it up to the experts to make that feature to the size that we have on the drawing in the most cost-effective way. Is that a drill? Is that a bore? Is that a ream? I don't know. Okay, we're going to let that up to them. Okay, so we never put a manufacturing process or a tool in back of our value. We would just put a diameter of 0.25, done. And now they get to decide how that's going to be made. Okay. When we talk about dimensioning angles, just like any other dimension, we do not put it on the part, okay? So this dimension really needs to go up and away. We never, ever dimension on the part. And that's one criticism I do have here. There are a couple places, and I'm going to point them out during this lecture, would not be acceptable for you to hand in to me. We never dimension on a part, okay? Don't do it out in industry either. You're going to see people who maybe have not been formally trained and aren't familiar with the standard. We do not dimension on a part. This needs to go out and away. We would actually create an extension line going up, and our 1/4 of an inch actually would be up and over off of the part. All right. You can dimension this in 2 different ways. So either putting the angle in place, or you could dimension the corners. And again, it's going to speak to the design intent and what is actually important. So either one of these would really get you, what you need, whether it's going to be the dimensions to the corners or the angle. Now, again, your angle based on the decimal that we have here is going to have a title block tolerance as well. Many times it's plus or minus 1/2 degree. Okay, so you need to put in the number of decimal places to be in accordance with the tolerance that you would be applying, which potentially would be the title block tolerance. When we dimension arcs, okay, because arcs are not full circles, we always dimension those as radiuses, okay? You would not put a diameter symbol in front of here and then put, double what that is. If it is not a full circle, we always put it as a radius. And the radius dimension, the capital R comes before it, okay? Now, when Creo sees these and dimensions it for you, kind of as in its attempt to create that detailed drawing, it'll put the R in front, okay? But you may need to move things around and such. Now, if you have a number of features that are the same, such as fillets and rounds, for instance, that are there's multiples all over the drawing, you can put a general note and say all fillets and rounds are whatever that dimension is, so that you don't have to dimension each and every one of these small little radiuses. Okay, it's a note that then defaults. That's called a general note. Okay, but anything that's not that, according to the general note, then what you need to do is you need to specifically dimension it. Okay. Now, the radius you'll notice here for our fillets and rounds is to 2 decimal places, so it still has a tolerance, and it's still going to default to our title block, just like other dimensions would. It's just that we're not physically putting it on there to save space, right? There would be a ton there, okay? All right, and again, you would not put the fractional equivalent. You would always put the decimal, Finish marks. Finish marks are going to be these little check marks that we can put on different features. And finish marks is how smooth or rough we are going to allow a surface to be. Now, If it's a general machined surface, for instance, like a 2 and a 3 place decimal, we don't have to put the finish mark on it because based on the manufacturing process, we're going to get that. But it's when we need it to be better than, or we can allow it to be worse than whatever the standard would be. We get into this more in working drawings. We'll be specifying these, okay? So I'm going to kind of hold off on the details on exactly that at that time, right? Now, as we look below, poor and preferred dimensioning. So as we look at the bottom of page 205, make sure that we're always pulling our dimensions away and off of the part, away and off of the part. We want to try to put them, near where that feature is going to be, okay, without crossing too many things. So in this case, you'll notice that we have a diameter of 1 inch. I would probably try to scooch that down and put it right down over here because the locational dimensions for that feature are closer to kind of this lower left-hand corner. Is this wrong? No, it's a simple part. I think it's totally fine the way it is. I would never take off points, but I just want you to keep in mind, if you're making that hole, you want to try to pull and you want to try to be as close to your feature as well as your locational dimensions as possible and have them all in the same view. So they do have those in the same view, but I would probably try to pull this down over here if I could. All right. And again, kind of playing around with the CAD, we can do that. But as we look over on the right-hand side, we would never, ever, ever dimension any of those on the part. That's what that means. We never put any of these dimensions on the part. People might say, well, it's easier to see. No, never. It's a violation of the standard. That's illegal in our world, illegal. So no dimensioning on the part. Additionally, up here, I think this is a great illustration. These are actually kind of like two sides here, okay? So on the left-hand side, we call this contour dimensioning, but you've heard me say a lot of times, we want to dimension where we can see the feature kind of as its true size and shape, right? So as we look here in the front view, we have this L-shaped bracket, okay? The front view right here, we see the two, if you would, the two edges of the feet where there's a cutout. Notice that the cutout is dimensioned in that top view where we see it as that cutout, all right? So the width of that cutout, where it starts from one edge, how deep it is, all up here, all right? Now, you could maybe put it down here because we see this edge as 3/4 of an inch, for instance, or the width. You could say that's a good place for it, but don't you think it makes more sense to see it up here? Like, because otherwise you're gonna have to look up and see what that looks like anyway. So why not put those dimensions where we see things as their true size? The same thing with the diameter of the hole that's going through here. Notice that it's in the view where we see that feature as a circle. So it has the diameter of 3/4 of an inch. And then additionally, we have a radius of 1.5. That's the radius that creates the width of this part. And then the width of the part has a parentheses around it. That's denoting that it is a reference. Now, you wouldn't have to put the 3 inches on there. It's nice, again, for reference, but it's not being cut to a length, if you would, of 3 inches. It's being radiused from that size. So this is the important dimension. This is the important dimension. Now, could you have the 3 inch as the important dimension, not reference, and then reference the radius? Yes, you could. But in this case, they're using that one, okay? Now the reference here, I'm always gonna tell you, don't put a reference on unless you see a true benefit of it. If it's something where somebody may wanna check it just to see, but in this case, I would probably keep that 3 inches off. It clutters up the drawing, it adds another thing for somebody to look at and to kind of wonder about, okay? So, and if for instance, you change your 1.5 inch dimension to 2 inches, now I know this is Creo, so it's a little bit different because the dimensions are parametric and they go along with the features, but potentially it could get forgotten to get rid of that 3 inches. And you just don't want that to happen. So it can cause confusions if they're not updated, okay? So I always err in, do I really need a reference dimension? Unless it adds clarity or for some reason somebody's got is requesting it, well, then maybe I'll put it on, but other than that, no. The other thing that we want to do is you'll notice that this hole right here, the 3/4 inch hole, in the view that we see it as a circle, that is where we're going to dimension its location as well. So notice the 2-inch dimension is over here. All right. And then we get the depth, the thickness of each one of the feet, the overall height here. And then lastly, you'll notice that we have the thickness of the upright portion. So this is all good, what we call contour dimensioning, dimensioning where we see the feature in kind of its best view or its true size. Okay. Now, over on the right-hand side, same part, all bad, all bad. So let's kind of look. So first of all, you'll notice that they have the 1/2-inch dimension here for the thickness of that upright. Now, yeah, we see it there, but you'd have to look around to see what that line is actually going to be. And that's over here in this view. All right, so better place over there. The location of the center line of the hole in the radius is up in that top view. It's actually dimensioning to the center line of a hidden feature. Illegal, illegal. The thickness here, you could maybe make a case for the 1.5, but isn't it better down here when we see it as an L in that right side view? When we look at the other one, I just think it's a nicer place. So again, reevaluate. You know, you might be like, okay, that's fine. And Creo will default to some of these places. It's, again, it's a machine. It's a software package. It isn't as smart as you are, okay? So you're gonna need and want to change those, all right? And here they're dimensioning to a hidden line and such. So, so any questions about kind of the violations over here and how the one on the left is way better. So I love when books put in like poor or incorrect and then do the correct method. You can kind of see that difference because sometimes you might be wondering when you're doing it, could I put it over here? But you can see side by side how much more clear the one on the left is. Okay. Always put yourself in the perspective of, how would I make this? If I was making this, what would I be looking for? One of the reasons that you guys get that experience in manufacturing processes in the shop, working on the milling machines and the lathes, is so that you can kind of go back to that experience and think about, how would I have set that up? Okay. Or the other thing is, if you're working at a company and you're sitting and wondering, should I put the dimension here or there or whatever? There might be somebody that you can walk out to the shop floor and ask them, like, how would you set this up? Where would it make sense? How can I help you? Okay, and that goes a long way. People really like when they're able to give that input. Okay, so remember, you're putting on dimensions once, you're trying to make them as clear as possible, and you're taking into consideration the person who's making it and that manufacturing process. Now, will you get it right perfectly every single time? Probably not. But as you gain experience, and especially when you're working at a company, you're going to get to know how they want it, okay? And you're going to start then, you know, getting really comfortable in it, and you will start getting them right the first time. But for right now, we're going to be, you know, using our standards, and I guess it's me you got to please, ish. Okay. When we see external diameters. So up until this point, we've kind of seen either the arcs, the external arcs are going to be radiuses, but then internal holes, for instance, are always going to be dimensioned on that circular view. But if we have solid shafts, for instance, or rods or pins, where it's a solid diameter instead of a, not that a circle is not a solid, it's like we're not removing material to make that circular feature. We will dimension it in the view that we see it. We call it the rectangular view. But what's wrong with what they have here? It's on the part, right? So again, criticism on their example, they're showing that we're not going to show this in the circular view. We're seeing it more where it represents exactly what that feature is. But this needs to be pulled off the part, off the part, off the part, okay? And then given the length in the same view. So notice that they're giving the size in the rectangular view for a solid circular feature or a cylinder like we see here, and its overall length for each one of those features as well. But again, these have to come off of the part. We are not dimensioning on. Not good practice there at all. Okay. So again, dimensioning cylinders. Notice this is better practice. This is turning the page on page 209. The diameters are off of the part. They are not on the circular view. They are on the cylinder view. And then their length is in that very same view, whether it's vertical or horizontal, okay? Same type of dimensioning. The radius of a cylinder should never be, a full cylinder should never be given. So again, if it's a full circle, we always do a diameter and such, okay? Now, criticism for this note up here, we do not put drill, we do not put tap, okay? And again, yes, a drill and a tap are going to be used, but on a drawing, we are non-manufacturing or tool specific, okay? Never. By this note, a half 13 UNC-2B, that is a threaded hole. And yes, we will use a tap to make it, but we don't need to tell them how to do it, okay? Same thing for up here. You'll notice that we have a diameter of 0.422. Again, we would not put the fractional equivalent. Sometimes people are like, well, it's nice to see. No, all right? And we don't tell them they're gonna drill it. They need to, we leave that up to the manufacturing professionals, the people who are gonna make it, to make that determination, okay? So we just put the decimal equivalent for the through hole, okay? Again, I have a little note in here, if you're reading every paragraph, do not put drill, don't put K, just put the decimal equivalent, that's it, okay? And they'll know, they'll line it up. So tapped holes should be attached to the circular view. That's what we actually saw right over here, okay? So they almost had it, but removing the items that we have crossed out here would be best. But we always do that in the circular view. Let's see here. Oh, keyways. We are going to come across some keyways and key seats. So it says dimension from the top or the bottom of a keyway to the opposite side of the shaft or the hole. So what they're referring to here is when, I wish they had a nicer view. I'm gonna draw it. I'm gonna draw it. And we're gonna see this reinforced in a couple of places, and I'll always let you know as we do it. Now, when we create a keyway, for instance, whether it's in CAD, AutoCAD, SolidWorks, Creo, we usually generate it from a surface, okay? That's like the top of the actual cylindrical feature itself. So if it's a hole or a bore, we usually, so we'll do our hole, for instance, and we'll put our keyway, we'll generate it from the top here, we'll like draw it, then we'll like get rid of this portion that's right there, okay? All right. But when we dimension it, the problem with that is even if we generated it from what would have been the quadrant that we removed, okay, when we put that feature, that keyway in place, because now this would be on a hub, if you would, and this is like an open. This is a hole with a keyway, okay? And that quadrant went away when we created that keyway, all right? So the problem, what a lot of people will do is they'll be like, oh, I'm going to go from this corner to the top here. That's also another dimension that if we would try to actually check that, we can't get at it. We can't get at it, all right? You can't physically get at it with like a calipers or anything. So what we need to do, the dimension that we can get, is even though, again, we're not creating it necessarily this way, but we've got to check this because we actually remove material. This is the dimension that we are going to be putting on all keyways, okay? From the bottom of the bore. Now, I can actually touch the bottom of that bore. I can touch the two inside surfaces here, and now I can compare that dimension to whatever that value is going to be for me, okay? Let's look at a key seat, a key seat. A key seat is going to be on a shaft, and it's going to be in the key. It's going to be machined in. So here's the top of this is a shaft solid, okay? And then I'm going to be putting the key seat in here that I can drop the key in. So if you would, this would be on the inside here. This would be a shaft with a key seat, and then my key would be between these two, and as I, and my key would be between them. As I rotate, now they rotate at the same RPM. That's the real purpose of a key, all right? So now when I dimension, this is called a keyway. And the one that's in the shaft is going to be the key seat. Okay, keyway, key seat. And then the key is in the middle. Now, before I go to the key seat, why would we do this? Why would we do this? Well, this piece right in the middle here, as I look at it, it's literally a rectangle, or a lot of times it's a square key, square cross section, but then it's going to have a length associated with it, with how long it is, like along that shaft. Okay, and then we make the key seat and the keyway to accommodate that. Now, as I rotate, if something jams up, where, for instance, the outside wants to keep going, but the shaft stopped, if I have this designed correctly, and you will learn this in Machine Elements, if I have this designed correctly, my keyway, my little rectangular piece that's super cheap to make and replace, is going to break before either one of these pieces will. All right, so by design, a keyway is made to fail at a certain point, so that if I were to break this and it's not going to work anymore, I'm not breaking the expensive stuff. Okay, so when I accommodate this key in my bore or in my shaft, okay, now I'm going to be putting my key down here in my shaft portion. The dimension here, again, when I would put it in there, I'm going to be removing that top portion. I don't have a quadrant anymore, so I need to dimension from here to the bottom. Okay. Now again, Creo, when you created it, it's going to use the dimensions that you used to create it. So when it drops in the standard dimensions, it's going to put them in from the top here, but you're going to have to remove those and then put in the appropriate one and add whatever an appropriate tolerance would be. Okay. So when we add the dimensions, and again, it comes down to, after that feature is made, I also have to check it. I can find this number here, right? I can't find something from a quadrant that I removed. Okay, the material's no longer there. All right, so this will come up again and again and again. So I wanted to talk about that here. On page 215, we're looking at holes that are equally spaced on a bolt circle, okay? So we have like two ways that we can call this out. First and foremost, when we show the bolt circle here, we're going to be using a center line to show that it's going through, in this case, 4 holes, okay? And you'll notice that they dimensioned that bolt circle with BC in back of it, so a diameter of 5 inches, bolt circle BC. They have that as its own separate dimension, which is great, okay? And then they have the call out for the 4 holes, a diameter of 0.5, and then it says equally spaced in back of it, okay? Now, if you don't have room for the full words equally spaced, you can put ES, and that's an abbreviation for that. So you can do equally spaced as ES. Now, the other way that we could do this is we could say 4 by a diameter of 0.5 equally spaced, and then on the next line on on a diameter of 5.00 BC. So you can put it all on one note because you're already showing that diameter on there. Okay, as long as you show the center line circle going through all of those points, you can see that that's the circle that it would be on. Okay. So you can either get it at one note, or you can get at it by 2 separate notes here. I believe Creo will default by dimensioning it 2 separate. And sometimes you just don't have the room, so you might have to combine, and it might be that, and that's okay. Another way that you can dimension holes, and it's completely legal, is to do it from the center line, okay? Sometimes you have different holes in different locations and they don't really line up with like equally spaced or at a certain angle or whatever it might be. You can do X and Y coordinates on circular features, even if you have something, if you would, on a bolt circle like we have here. Here they're referencing it, so you can kind of see they're all in line, but giving specific locations from a known, in this case, center of the outside diameter there. That's okay too. That's okay too. Just really depends on, you know, what it's mating with and what's important. Okay. All right. Kind of continuing to do some more do's and don'ts. Another one that I want to call out on the book is here on page 216, this locating holes for figure 735. It's okay to do the dimension between as we see here, but we need to pull that off the part. We need to pull that off the part, all right? Okay. And then there's a little section here on notes, and I think it's worth mentioning here as well. There are two different types of notes that we're going to see on drawings. The first type is a general note. A general note is something that we can put like all fillets and rounds are 0.12, a radius of 0.12. That's a general note, all right? And we can put it then, typically it's going to be either right above the title block, or it's going to be like, if you have a B-size drawing, it's going to be in that area kind of down into the left of the title block, okay? We keep all general notes together in one place on a drawing, okay? We don't scatter them all over because they can be missed otherwise, all right? So general notes need to have their own kind of area where they're all going to be, okay? And readily, you know, readable. So and this is where companies sometimes will dictate, like, this is where we put all of our notes so that we always know on our drawings where to look, okay? Nowhere else. So whether it's to the left of the title block or directly above the title block or in an upper right-hand corner, a lot of times a company will say that's where we want them, okay? If they don't, I think the suggested places, like I said, in those one of two places, above the title block or to the left. Okay, that's general notes. So again, kind of adding on like something that applies to everything. Local notes are going to be ones that are going to have, for instance, like a leader line, like we see here. So if there's a specific area, now, yes, this happens to be a manufacturing, you know, note, carburize, harden, and grind. Okay, carburize, harden, and grind. Now, in this case, because, and this would be an exception, and there's always going to be little exceptions to the rule, but it's a good explanation of, here is a note, and it is going to have a leader pointing to the area, the diameter that this applies to. Notice it doesn't apply to the overall part, so adding this for exactly where they need it to happen is okay. But I will say, we're going to remove ream from here, and we're going to put the actual tolerance on here, okay? And we are not going to reference the taper pin, okay? Especially not when we have drawings that are made to for, how can I say this, mass production, okay? We are going to see an exception to this when, and it's really not an exception, it's just a different type of a drawing, tooling drawings, when you guys do tool design next semester, okay? That's a different animal, and we'll explain how it's different. But here it would not be appropriate, okay? You can add, for instance, over here, you'll notice that they have a diameter of 0.82 by, and it says 0.1 wide thread relief, okay? I'm not crazy about the thread relief, but I would probably just leave it at relief. But there's probably, I think there's room for the 0.1, so I think it's better to dimension it, but they chose to put it as a note. And that's okay. That's okay. All right. But better to put it as its actual own dimension. All right. So, so those are kind of examples of general notes and then local notes, as they're called, okay? And then the last section I want to call our attention to is dimensioning for numerical control. So dimensioning from a numerical control is when we are recognizing that there's a good chance that there is going to be a CNC machine that is going to make our parts. And typically the CNC machine, well, it doesn't typically, it always needs a program that it needs to read. And those programs are generated from geometry that we create in our models, okay? And when we dimension, we have to first and foremost always take into consideration the final function of our parts and what the mating pieces are going to be. But number two, we also have to consider the manufacturing process. So if there isn't any, functional reason not to dimension from, for instance, a baseline, the programmers and the CNC machines are going to be very happy when you have a 0 point and then you just have locations from that 0 point in the X and the Y directions. So baseline or ordinate dimensioning is going to be a dimensioning style that when you know a CNC machine is going to be used, you want to exercise that. And we'll see those differences. We'll show those, along the way. What that means is then all of your dimensions will be in decimals. And we've already said that the standard says they're all going to be in decimals. And then your angles would be specified in coordinate dimensions rather than angles or degrees themselves. But you can program those in as well, so not super critical. And then it says here, standard tools such as drills, reams, and taps should be specified if known. No, we don't do that, okay? That one I'm saying, nope, we're not doing. We don't want to put a ream in back of something. We don't want to put a drill in back of something. Do we want to keep things to standard sizes that we know drills are made to? Yes, but we are not going to put in the back of 0.25 drill. No, we're leaving that off, okay? It's up to the manufacturing process to create, or the manufacturing people process, the programmer to decide what tool they're going to use for that, okay? And then at the very end here, and some of these have been mentioned as we've gone through, not each and every one of them specifically, but from starting on page 219, checklist for dimensioning, all right? There are 47 things over the next 2.5 pages here that you want to keep in mind. Now, I am not going to read each one of these to you, but it's a nice list, again, to kind of pull these things back into the front of your mind as we're going into creating detailed drawings, okay? Now, for this portion of the chapter, this is where I'm going to stop. As we turn the page, the next thing that we're going to be doing as part of our assignment in this learning plan, you actually have 2 assignments here. One is going to be review questions as they pertain to the dimensioning that we just went over, okay? And the second part is going to be creating drawing borders, okay? It's going to be an A-size border in 3 different configurations, okay? The next time that we meet, I am going to be demonstrating that portion of it. And that's going to then go to the end of our chapter. Now, as we make our way to the physical end of our chapter, past this tutorial to make your drawing borders, on page 244, there are review questions right here. I took these review questions and I put them in Blackboard, and you have an assignment then in Blackboard to turn in the answers based on the information at the beginning of this section, or of this chapter. So if I minimize this window and I go to my LP6 homework folder, okay, and you'll notice that there are 2 drop boxes here. The LP6 tutorials are for the drawing border generation, okay? And it's going to be the second half. And then actually I'm going to put these in, I'm going to put the review questions up top, because those are actually, let's do those first. The review questions have to do with the dimensioning stuff that we saw here. So when you go into the review questions, you're going to notice this is a Blackboard submission, okay? So it's not like you're going to write them out and then scan and upload. You're going to put your answers, you're going to type them in for me here, okay? There might be 1 or 2 multiple choice, but it's really the questions that are at the end of the chapter. I pulled those, and you're going to put your answers in here, okay? And then I'll go back in and correct them from here, and then you'll get them graded out, okay? So I'm going to save and submit. I'm going to say okay, and it's going to be like, yeah, no, I got them all wrong, okay? Or it's actually, I'm sorry, it's going to say needs grading, because you're going to be actually putting your answers in, writing them out, and then I'll be going over your answers to be sure that they make sense. And you should be able to find the answers to those through this lecture, but then also through the work in the book. Okay. So any questions? Keeping in mind that the couple of things that I did point out in this lecture, like keeping off manufacturing processes, you know, off of the notations for things. Also, you can't, you know, they were putting some dimensions on parts. We never do that. Okay. So there's a couple of things that I kind of pointed out. Make sure that you answer in the way I told you, not the way the book did. All right. So I'll know if you actually watched my video or not, or if you were here. So, okay. That's all that I have. Do you guys have any questions right now? Any questions at all? All right, so the next time we meet, we'll continue on in this particular learning plan. We've got a little bit more work to do, but this gives you something that you can kind of get started on, and again, review your knowledge on dimensioning. None of this is new to you, but it's good review, okay? All right, I'm gonna stop sharing, I'm gonna stop recording, and I'll be back for our next learning plan the next time we meet.